equation. So we have to find out the unknowns here. In all the equation, only one unknown is there, that is theta b. So theta b, rotation at joint B. So next one, third step, we have to write joint equilibrium equation. Joint equilibrium equation. So this is the given beam. So here this is fixed support, here roller support. Okay, so here fixed support. So end moments will be developed here. No, this is. So already we have calculated fixed end moment as well as end moment. So this is M AB, M BA, M BC, then here M CB. These are all the end moments. So already we have formulated the equation for this MAB, MBA, MBC as well as MCB. Okay. So in all those equations, theta B is unknown. Theta B means rotation at joint B. Okay. So we have to write down the joint equilibrium equation at joint B because unknown is theta B only. So we have to write the equation here. So at joint, the sum of moment equal to 0. So always at the joint, the sum of moment will be equal to 0. Then only it should be maintained the stable condition. Okay. So now write down the joint equilibrium equation at B. That is sum of moment about B equal to 0. So at joint B, MBA is there, MBC is there. So write down MBA plus MBC equal to 0. So this is joint equilibrium equation. MAB plus MBC equal to 0. So already we have formulated the equation for BA, MBA as well as MBC. So substitute here. So equation number, I think the equation number MBA is 2, MBC is 3. So substitute equation number 2 and 3 here. That is MBA equal to 20 plus EI theta B plus MBC equal to, this is MBA equation, MBC equation equal to minus 60 plus 1.33 EI theta B equal to 0. Okay, so if you simplify this one, so finally we can get the answer theta B. So theta B equal to 17.143 divided by EI. This is the value of 17.14. This is the value of theta B. Okay. So after finding this one, theta B equal to 17.143, we have to substitute in the equation from the equation 1 to 4. See here, this is equation number 1. In the equation number 1, theta B is unknown. So we have calculated the theta B value, that is 17.143 divided by EA. So we have to substitute here and find out the, so what is the end moment at A. So similarly we have to substitute theta B value in equation number 1, equation number 2, equation number 3 and equation number 4. So if we substitute, we can find MAB value, MBA value, this is equation number 1, then MBC, then MCB. Okay. So the answer is MAB equal to minus 11.428 kilonewton meter, MBA equal to 37.143 kilonewton meter, 71.429 kilonewton meter, then MCB minus 37.143 kilonewton meter. So here 71.429 429 kilonewton meter. So we have written the joint equilibrium equation at B. So sum of moment at B equal to 0, that is MBA plus MBC equal to 0. So see here, MBA plus MBC equal to 0, plus 37.143 minus 37.143. So now next one is we have to draw the bending moment diagram. So before drawing the bending moment diagram, so we have to calculate the simply supported bending moment. That is the sagging bending moment. Transverse load produce the sagging bending moment. So for the span AB, okay, span AB, it is simply supported bending moment. The maximum bending moment at midspan only, because the point load is acting at the mid. So maximum bending moment when the beam is subjected to mid load, the formula is WL by 4. So substitute here, so we can find out the answer. So W equal to here 40 kilonewton, L equal to 4, divide by 4, the final answer is 40 kilonewton meter. So next one's for the span BC. So it is subjected to UDL load. If the beam is subjected to UDL load, the maximum bending moment at midspan only. The formula is WL squared by 8. The maximum bending moment. So already we have studied in the third semester itself. So WL squared divided by 8. Okay. So the W equal to 20. Length is 6 divided by 8. 20 into 6 square divided by 8. We can get 90 kilonewton meter. So this is simply supported bending moment diagram. These are all the end moments. So it produces sagging bending moment, positive bending moment. So always end moments produced hogging bending moment. That is the negative bending moment. So we have to draw the combined bending moment diagram. We have to combine this negative bending moment as well as this positive bending moment diagram. Okay. So this is the baseline. This is point A, point B, then point C. So first I am going to draw the positive bending moment, that is simply supported bending moment diagram. Both are positive only, value is also positive. So we have to draw above the baseline. Span AB is subjected to point load. Okay. So the diagram is only the straight line. So 40 is here. This is 40. So next one, coming to span BC. Okay. So this is 90 kilonewton meter. So the beam BC is subjected to UDL load. So for the UDL load, the bending moment diagram is parabolic. And where is this one? This is B point. This is 40. And this is 90 somewhere here. This is parabolic. This is 90. And this one is 40. This is simply supported bending moment diagram. So now we have to draw these end moments MAB, MBA, MBC, MCB. So this is for span AB, this is for span BC. For the span AB, this is left side and this is right side. So coming to span BC, this one is left side and this one is right side. Okay. So now the sign convention is left side anti-clockwise moment, right side clockwise moment. If we get the answer, left side anti-clockwise moment and right side clockwise moment means, so we have to draw above the baseline. We have to draw above the baseline. This is the baseline. No, we have to draw above the baseline. So because the hogging bending, this is the hogging bending moment. No, hogging bending moment. So left side anti-clockwise moment and right side clockwise moment means it producing negative bending moment. So this type of moment we have to draw above the baseline. Now coming to the span AB. This is left side, this is right side. Left side anti-clockwise moment, that is minus sign. Right side clockwise moment, that is positive sign, means we have to draw above the baseline. So this is minus 11, no? Minus 11 somewhere here. 37, here 37. This is 37. 11 and 37. Now coming to span BC. For the BC, this is left side and this is right side. Left side anti-clockwise moment, right side clockwise moment means we have to draw above the baseline. Okay, so this is also match with our sign convention. Left side anti-clockwise and right side clockwise. So minus 37, same point, and here 71.429 here. 71.429. Now connect this one. Okay, so here positive bending moment also there, negative bending moment also there. Both will compensate each other. So we have to shade extra bending moment. This is the extra, these are all the extra bending moment. Okay, so this is negative, this is positive, this is negative, this is positive, this is also negative, positive and negative. Okay, so this is 71.429. Okay, so this is combined bending moment diagram. So we have to show positive bending moment and negative bending moment in the same diagram with respect to same baseline. So this is the combined bending moment diagram. So next one is shear force diagram. So shear force, what do you mean by shear force? Shear force means algebraic sum of vertical force either left side or right side of the section. So for that we have to calculate the support reaction first. Okay, the final step is shear force diagram. Okay, so draw the free body diagram, remove all the support. So only mention the support reaction. So here it is, in A is fixed support. It has one vertical reaction as well as one end moment. Coming to B, it is the roller support, then one vertical reaction. End moments also there because it is a continuous one. Here also one end moment is there. Okay. So this is MAB. Already we have calculated MAB. That is MAB equal to 11.24. Okay. So here this is anti-clockwise, no, 11.2 for MAB. This is MBA. So MBA value is 37.43. 37.43. Here MBC, this is MCB. So this is also 37.43 and MCB equal to 71.429. 71.429. So it is subjected to point load 40. Okay, this is UDL, that is 20. Okay, 20. Then span is, this is 2 meter, 2 meter, 2 meter, 2 meter. This is 6 meter. Then this support reactions RA and RB, then RC. Okay, so we have to find out this unknown support reaction RA, RB, RC. Okay, so I am taking span AB. Okay, this is AB, RA, RB. So this is end moment 11.24. Here 37.43. This is 40. Here 2 meter. Here 2 meter. So now I am considering this section here. We can consider this section either left side or right side. Here I am considering section at the right side of the beam. Right side of the beam. So here we have to consider begin this section, otherwise this section we have to consider for finding the support reaction. So I am considering back side of this section. Okay, this is right side, section is on a right side. Now taking moment about point B, this is point B. Taking moment about point B, so now RA, so it is producing clockwise moment is positive. So RA into the moment means force into the perpendicular distance. So here to here the perpendicular distance is 4 meter. So next moment is there Actually it is moment, no need to consider the perpendicular distance. This is anti-clockwise moment. For the anti-clockwise moment, the sign is minus sign, minus 11.24. Now coming to this 40, this is a point load. It is producing anti-clockwise moment about point B. So anti-clockwise moment means minus sign. The point load is 40. We have to consider the perpendicular distance from here to here. If the force is vertical force, we have to consider the horizontal distance. Okay, this distance as a perpendicular distance of for this point load. So here to here 2 meter. Now coming to here, this is clockwise moment plus 37.43. Okay, this will be equal to 0. If you consider RB, there is no perpendicular distance here. Okay, so 0 only. Now find out RA. So taking moment about B, here this is moment about B. So RA value equal to 13.52. 13.52, the unit is kilo Newton. Next one we have to calculate RC. Okay, so consider this portion. So consider only this portion. Okay, take this section here, left side of span BC. So consider only this portion only. Either we can consider this one, otherwise this one. So this is RB and this one is RC. Here 37.43. Here 71.429. UDL load is 20. Length is 6 meter. Okay. Now consider the section here. Okay. Right side. Okay. If you consider the section at right side, okay, the sign convention is different. So here clockwise is negative, anti-clockwise is positive. Okay. So now taking moment about point B. Okay. Here also moment about point B. Okay. So RC. So this is producing which moment? Anti-clockwise moment. Okay. If the section is the right side, the anti-clockwise moment is positive. So RC into 6. Coming to this load, this moment. So this is producing clockwise moment. So clockwise moment is minus sign if the section is the right side. So this is UDL load. This is also producing clockwise moment about point B. So minus sign, minus 20 into 6 into 6 by 2. So we have to convert this UDL load into point load. 20 into 6. This point load act at the mid of this UDL load. From here to here, the distance is 3 meter. Okay. So then again, we have to add this anti-clockwise moment. Sorry, this is section is the left side, no? Sorry. The section is left side. Anti-clockwise moment is positive. That is 37.43 equal to 0. Here the section is left side, not right side. Okay. So now, solving this equation, we can find out RC. RC equal to 65.714. 65.714. So out of 3 unknowns, we have determined 2. That is RA, RA and RC we have determined. So remaining one unknown is RB. Okay, we know the equation of equilibrium, no? So now sum of all vertical force equal to 0. Using that equation, we can easily find out RB. So how many support reaction, vertical reactions are there? RA. So upward force as considered as a positive force. So plus RA minus 40 and minus 20 into 6 plus RC equal to 0. Okay. So using summation of vertical force equal to 0. Sum of vertical force equal to 0. Okay, sum of vertical force equal to 0. RA is acting upward, so positive. RB also acting upward, so positive. RC also acting upward, so positive. And 20 kilonewton is acting downward, sorry, 40 kilonewton, so minus 40. Then UDL load is acting downward, so minus sign. We have to convert that UDL load into point load. So intensity of the load into length of the span, we can get the point load. So this will be equal to 0. Here we have to consider only the vertical force, not moment. Sum of vertical force equal to 0. Already we have determined RA and RC. So substitute the values here. RA equal to 13.52. Then RC equal to 65.714. 65.714. Substitute here. Finally, we can determine the RB value. So RB equal to 80.766. Okay, this is RB value. So next step, we have to draw the shear force diagram. What do you mean by shear force? Sum of vertical force either left side or right side of the section. So for that, we have to draw the free body diagram. We have to mention only the vertical force. No need to mention the moment. So RA value is 13.52. Then RB value 80.766. Then RC value 65.714. Then midpoint load, and this is UDL load. Midpoint load is 40. UDL load is 20. These are all the vertical force. This is A, B, C. Okay. So shear force means sum of vertical force either left side or right side of the section. So each and every point, okay, I am going to divide into two sections. So one is left side, okay. Another one is right side, okay. So this is A1, this is A2, A11 and A22, okay. A11, A22. So find out A11. A11, okay. So A11 means this is the support, okay. So these are all the section, okay. Back side of section there is no force, so 0. This is point A, okay. Now find out A22, okay. So this is point A. So this is A22. Okay, back side of this 22, one more force is there, one force is there, that is RA. What is the RA value? RA value 13.52. Okay, 13.52. Upward force is positive force, so plus 13.52. Okay. So next one. Similarly, this is, shall we write D? Okay. So this is D. D11. D11. Here. So what are the forces available on the back side of this D11? This is D11. Okay. So this is D11. So back side of this D11, only one force is available, that is 13.52. It is acting upward. So D11 equal to 13.52. Next one, D22. Okay. D22 means this is the section D22. So back side of this D22, what are the forces are available? One is upward 13.52, another one is acting downward minus 40. So plus 13.52 plus 13.52 minus 40. Okay, plus 13.52 minus 40 minus 26.48. Minus 26.48 kilonewton. Okay, so now coming to P11. Okay, this is B11. B11 also same value, plus 13.52 minus 40. B11 same value, that is minus 26.48 kilonewton. Next we have to find out B22. B22. B22 means this is B22. Okay, back side of this section, one more value also added here, that is 80.76 is. So plus 13.52 minus 40.2 plus 80.766. So already these two values we have calculated here. So minus 26.48. Again we have to add one more value, that is minus 80.76. So the answer is 54.28. So this force is acting upward, so positive, the 54.28 kilonewton. So now C11. Okay, so C11 means here, this is C11. So we have to consider this UDL load also. This is acting downward. Downward means negative sign. So C11 equal to, so this is 54. Before we have calculated 54.28, no? So this one we have to add this UDL also, minus, convert this UDL load into point load. Okay, C11. So C11 equal to minus 65.72. Minus 65.72. So next one, calculate C22. Okay, C22 means, so this is the section, no? C22. So one more force is there, we have to add 65.74. This is acting upward, so plus sign. So already in previous value minus 65.72. So minus 65.72. Add one more value 65.74 plus 65.74 equal to 0. Okay. So after calculation of this one, draw the shear force diagram. This is A, B, C. A11 is 0. A22 is 13.52. This is 13.52. D11 also, this is D point, no? 13.152. 52. D11. D22 26. Minus 26. Minus 26 means here. Minus 26.48. So next one B11. B11 also minus 26 here. Then B22 54 plus 54. Plus 54 means here. 54. Then C11 minus 65. C11 minus 65 means somewhere here. Because this is 26, no? 26.48 minus 65.72. C22 equal to 0. Now we have to connect this, all those things. Okay. This is 54.28. Now this is positive shear force. This one is negative. Positive, negative, positive, then negative. This is called as shear force diagram. Okay. So I have completed the one problem using how to analyze the beam using slope deflection method. Okay, the first one is find out the fixed end moments, and second one is write down the slope deflection equation. After that we have to write the joint equilibrium equation. Using joint equilibrium equation we have to find out the unknowns. So we have, after that we have to substitute that unknowns in the slope deflection equation. Finally we have to calculate the end moments. So after calculating the end moments, So we have to find out the simply supported bending moment. So after that, draw the bending moment diagram. Then we have to calculate the unknown support reaction. So after that, draw the shear force diagram. That's all. Thank you. We will see in the next class.